Yes, let's see this case. Two identical pith balls, this word is actually equal to 2. Two identical pith balls are charged by rubbing against each other. They are suspended from a horizontal rod through two strings which are at a length of 20 cm each. The separation between the suspension points is 5 cm. In equilibrium, the separation between the two balls becomes 3 cm. Find the mass of each of the ball and the tension if the charge has a magnitude of this much. That is equal to 20 into 10 to the power minus 8 coulombs. It's actually not 20, it's 2 into 10 to the power minus 8 coulombs. There is a slight correction over here, so please make it. Now basically what happens is, two pith balls are rubbed. What happens on rubbing is electron transfer takes place. If electron transfer takes place, one would be a positively charged body and one would be negatively charged, such that charge on both the balls can be written as equal to 2 into 10 to the power minus 8 coulombs. Now if charge on both the balls can be written as 2 into 10 to the power minus 8, one is plus 2 into 10 to the power minus 8 and the other one is minus 2 into 10 to the power minus 8. Hence the bodies come closer towards each other. Now if the bodies come closer towards each other, let's see how does the scenario work over here. If the bodies come closer towards each other, initial point of suspension was at a distance of, initially the bodies were something like this. Now they attracted each other and finally came down to this particular position, where the final separation between them was given to you as 3 cm and initial separation was given to you as 5 cm. I'll continue this problem on the next page. The situation is something like this. That we have 2 points of suspension which are at a distance of 5 cm and the two pith balls eventually come down to a distance of 3 cm. Due to symmetry, we can state this thing that one side this distance would be 1 cm and the other on the other side also the distance would be 1 cm. This is the proper scenario which we are getting over here, and the length of the strings is also given to you as 20 cm. Let's call this angle to be theta. This side is 1 cm, the above side is 20 cm. If this angle is theta, this can also be stated as theta with this side as 1 cm and this length as 20 cm, such that sin theta in this case comes out to be equal to 1 by 20, and since sin theta is small, this can approximately be written as equivalent to tan theta also, and cos theta can roughly be written as 1. Now if this is the case over here, let us just consider the other parts of this case. If we consider the other parts of this case, see, the system over here would be at equilibrium. Now if you consider one of the blocks or one of the pith balls, it would be facing a couple of forces. One is mg in this direction, other is tension T in this direction, and the third one is an electrostatic force in this direction, such that if this angle is theta, this angle would also be theta, and if that angle is theta over here, this particular angle would also be theta. Now the net force on the pith ball would be equal to 0. This simply applies that we can apply Lami's theorem. Or let's take the components of this part. If I take the components of this part, this component would be equal to T sin theta and the upper component would be equal to T cos theta, such that T cos theta would be equal to mg and T sin theta would be equal to F electrostatic force. This becomes our equation number 1 and this becomes our equation number 2. I'll be shifting the page now. Basically what equations do we get as? That is T sin theta is actually equal to Fe which is our equation number 1, and t cos theta is actually equation number, t cos theta is equal to mg becoming equation number. Let's divide 1 by 2. So t sin theta by t cos theta, which can be written as tan theta, can also be written as Fe by mg. So mg becomes Fe by tan theta, where Fe can be written as k q1 q2 divided by r square into 1 by tan theta. Keeping the values of k and charges, k is given to you as 9 into 10 to the power 9. Both the charges are 2 into 10 to the power minus 8. So let's introduce a factor of square. Final separation between them is 3 by 3 centimeter or 3 by 100 whole square into tan theta can be written as 1 by 20, as we have mentioned it over there. So basically, on solving this part, we get a particular value that the electrostatic force into, on solving this particular equation, let's see what does things come out to be. See, this 3 square and 9 gets cancelled out. The first part is 4 into 10 to the power minus 16 into 10 to the power 9 into 10 to the power 4, whole thing divided by 20, which makes it 10 2, or 2 into 10 to the power minus 17 into 10 to the power 13, or 2 into 10 to the power minus 4. That would be the outcome to this part. If this is 2 into 10 to the power minus 4, there has been a slight calculation error.